The exercise is related to measuring mass, weight, and density. That is also a weekly homework. You have to solve and submit. So first question, figure 3.1 shows an oil tank has a rectangular base and of a dimension 2.4 by 1.5. So the dimension of the base is given and the depth, the depth of the oil inside is also given. Calculate the mass of the oil. So how we can work out the mass of the oil? We have the density of oil. First, you have to recall the formula which you use to calculate a density. So we have the formula, the density is mass divided by volume. So if density is mass over volume, if we need the mass, it will be density times volume. What about the density? The density is given 850. And what about the volume of the liquid inside? Uh, if the whole uh, container was filled with the liquid, then the volume of the liquid will be equals to the volume of container. But as you can see, the whole container is not filled with oil. Some part is still left. So how to work out how much liquid is there inside? So we'll measure the volume occupied, like the space occupied by the liquid. So the space occupied by the liquid, we have the length, we have width, and we have height. So we multiply them all, like it will be 2.4 multiplied by 1.5 times 1.5. So we multiply by them all, we'll get the mass of this, which is equals to 4,590. So the mass is equals to 4,590, and the unit, because the density is in kilogram per meter cube and the volume is in meter cube, so we'll get the mass in kilogram. The density was in gram per centimeter cube and the volume is in centimeter cube, we'll get the mass in gram. Is it clear discussion? The next question, when checking the level of oil in a tank, a man drops a brass key and it sinks. So, for example, when checking the level of this tank, a key is dropped and that sink. So, if the key sink into this, what we can conclude about this? What we can say? What about the density of the key or the brass compared to the oil? As it sink, move towards the bottom. So we can say that the density of the key or brass is more than density of oil. So what this shows about the density, of the brass, we can say that the density of the brass is more than oil. Explain how attaching a key to a piece of a wood prevent the key from sinking. Like if you attach a piece of wood to this key, it won't sink. So what is the reason? Why? So when like a key and wood both are attached with each other, it does not sink. So we can say the combined density, yeah, wood is less than, that's good. Or you have to say use the term combined density, because it's not only the brass is there, like when the key was not attached with the wood, it sink. But when the key is attached with a piece of wood, it does not sink. So what is the reason for that? Like a piece of wood and the key. So we'll say the combined density of a key and wood is less than the oil. That's why it does not sink. So here the combined density, because you cannot say only about wood as it is wood and key together. So you have to mention the combined density of wood and brass, or you can say key, is less than oil. So when density is less, that object will float. Less than or equal to, it will float. Otherwise, if it is greater, then it will sink. In question 2, figure shows a remote sensing equipment on the surface of a distant planet. The mass of the equipment is 350. And acceleration of a free fall. Acceleration of a free fall, also known as the value of a gravity. So gravity of this planet is 7.5. Because acceleration of a free fall means if an object is allowed to drop freely under the effect of gravity, it will accelerate, and its acceleration is always equals to the value of gravity. Like for Earth, the gravity we say 9.8, and acceleration due to gravity is also 9.8. Same thing for a moon. The gravity of the moon is 1.6, so acceleration due to gravity of the moon is also 1. What is meant by the term weight? So how we define the term weight? Weight is actually a force of a gravity or a force acting on an object, or force of a gravity acting on the object. Then calculate the weight of equipment. Part A2. So how to work out the weight of equipment? Weight is equals to mass times gravity. So what is the mass? It is 350. And what is the gravity of this planet? That is 7.5. Because the acceleration due to gravity is same as the value of gravity. So it was 2,625. So weight is equals to 2,625 newtons. Weight is a force, that's why the unit is newton. Now, the equipment releases a balloon from a point that is a small distance above the surface. Like this is the surface of the planet, and equipment releases a balloon. So there's a balloon example here, just a small distance above the surface. The atmosphere of this planet has a density of 0.35 kilogram per meter cube. So density of the atmosphere or density of the surrounding, or you can say density of a fluid, is 0.35. The volume of the inflated balloon, this is the density of the air or atmosphere, you can say. Then the mass of the balloon is 80 grams, and it occupies 0.3 meter cube. But first thing, the question is make an appropriate calculation, predict weather, predict and explain the direction of any motion of a balloon. How we'll predict the direction of motion? If we find that the density of a balloon is higher than the density of the surrounding air, it will sink. If the density of a balloon is less than the density of surrounding air, it will float or it will rise up. So first we have to find the density of a balloon. But to get the density of a balloon, the surrounding air density is kilogram per meter cube. But density of a balloon, the mass is given in grams. So to get the density of a balloon, the mass of a balloon, but that is given in gram, 80 gram, we have to convert into kilogram, because the unit of a density for atmosphere is kilogram per meter cube. So we divide by 1000. This will be 0.08. Now, to get the density, it is mass over volume. So mass of a balloon is 0.08, and the volume of the balloon is 0.30 or 0.3, you can say. So it will give us 0.267, 0.267 kilogram per meter cube. So density of this balloon is 0.26, or you can also say 0.27. Because it's 0.267, so I can say 0.27 or 0.267, both are correct. So the density of a balloon is 0.267, but the density of air is 0.3. Where this balloon will move, upward or downward, as the density of a balloon is less than the surrounding?
Upward.
It will move upward. So it will go upward here. So prediction, we can say it will float or it will move upward. And the reason is that the density of a balloon, I'm writing in short, is less than density of air. You will write in words because it's a 4-mark question. How the marks are distributed? 1 mark is for just writing this formula or showing a substitution. So in physics, it's very important that you write a formula you're using to solve. So 1 mark is for writing a formula. 1 mark is for getting this answer. 1 mark is for mentioning it will move upward or float. And 1 mark is for the reason that the density is less than, density of a balloon is less than atmosphere. Moving on to the next question. A block of wood has a volume of 210 and the mass 180. We need the density. Why it's of 2 mark? 1 mark is for just writing a formula. You can write density is mass over volume, or you can also use a Greek alphabet. Rho is equals to m by v. Mass equals 180 and the volume is 210. So this will give us 0.857. So this will be 0.857. And the mass was in gram and the volume was in centimeter cube. So the unit is gram per centimeter cube. If mass was in kilogram and the volume is in meter cube, then the unit will be kilogram per meter cube. The block is held just above the surface, a density of a liquid density 0.8. Now, like we have a liquid which is having a density of 0.88, and we have this block which is having a density of 0.857. What will happen to this block? It will float or sink?
Float.
So it will float, and reason is that because the density of a block is less than density of the liquid. So 1 mark for mentioning it will float, and second mark is for reason because the density of block is less than, don't use this like symbol, write in word, I'm using this as a short form, is less than the density of liquid. As I did not mention a type of a liquid or name of liquid. If there is a slight change, yeah, even look, the idea is that if a density is less or density is equal, it will float. If density is only more, then it will sink. Moving on to the next question. The question is a container, a rectangular container is there having a dimension of 0.12 and 0.16. And it is filled with a liquid. Like there's a rectangular container is there. And the dimensions are there for this one. This is 0.16. This is 0.1 meter. First thing, calculate the weight of a container. The mass of a liquid is 4.8. Like the total liquid inside is 4.8. So we need the weight. So how to get the weight? Weight is mass multiplied by gravity. Mass is 4.8 and the gravity is 9.8. Like old past paper, it was 10, but you are supposed to take as 9.8. So you will get 47.04. Write your answer in 3 significant figure or 2. So we can also say 47 because it's like 47.004. It's 4 significant figure. 3 is correct. So when I rounded off, it will be 47.0 Newton. The depth of a liquid is 0.32. So the liquid, like it is filled with a liquid and there's a liquid with a depth of 0.32. We need the density. So how to get the density? Density is mass over volume. The mass of a liquid was 4.8 and the volume, because it's a rectangular, so length, width and height. So 0.12 times 0.16 times 0.32. We multiply all of them. So it will be 781 kilogram per meter. Because the mass was in kilogram and the volume is in, like length, width and height were in meters. So we get in meter. Question 5. Figure 1.1 shows a piece of a glass which is 2 centimeter thick and area is 0.15. The density of a glass is 2.6 exponent 3. Calculate the weight. So how to work out the weight? Because to get the weight, we need mass and gravity. So we know weight is mass multiplied by gravity. We have the gravity, which is 9.8, but we don't know the mass. So first we have to find the mass. How to work out the mass? So we have the density. Density is mass over volume. So density times volume will be equals to mass. What is the density? The density is 2.6 into 10 to the power 3. But the volume is, this is area that is in meter square, but the thickness is in centimeter. You cannot multiply them because one is in centimeter, another one is in meter square. You have to convert the thickness into meter as well. So how we'll convert thickness into meter? We divide it by 100. So this will be 0.02. And what is the volume? Volume is actually area multiplied by thickness or area multiplied by height. So area is 0.15 and the height is 0.02. So mass is 0.02 times 0.15 times 2.6 exponent 3. So this will give us the mass of it, which is 7.8 kilogram. Okay. So mass is equals to 7.8 kg. After getting the mass, we need the density, we need the weight. So mass multiplied by gravity. So 7.8 multiplied by 9.81, which is equals to 76.4 Newton. So this is equals to 76.4 Newtons. Is it clear, this one? Anyone having a doubt or a question at this point? Then a microphone is in a recording studio has a mass of 0.55 kilogram and a weight W. Calculate W. So how to calculate W? The weight is mass multiplied by gravity. 0.55. Some question the mass is given in gram, so you have to convert into kilogram. 0.55 multiplied by 9.8, that will be equals to 5.39 newtons. Define density. For definition, density is mass present in unit volume. In physics, sometimes, like even when they ask define density, if you write a formula, so they accept. A density of aluminium is 2.7. The thickness of a rectangular sheet is less than 1 millimeter. The student wishes to find the average thickness you obtain by measurement. So first thing, we need the volume. Look, here the density is given in gram per centimeter cube. So we need the length in centimeter and mass in gram. So if we need the volume, we have the formula that density is mass over volume. So if we need the volume, and to remember this formula, remember this triangle, like the density, mass, and volume. So if I need the volume, it is density divided by mass. The triangle is density, mass, and volume. So if I need the volume, volume is mass divided by density. So volume is mass divided by density. What is the mass of the sheet? That is 60.7. And what about the density? 2.7. So 60.7 divided by 2.7, that is 22.48 centimeter cube. So the volume is 22.48 centimeter cube. calculate the average thickness. How to work out the thickness after getting the volume? If we have the volume and it's a rectangular sheet, the volume of the rectangular sheet is length, width, and height. So we have this answer 22.48. So if we need the volume is equals to length into width into height, or you can say thickness. So volume is 22.48 centimeter cube. The length of the sheet was 50. The width of the sheet is 30 and the thickness we don't know. If we need thickness, 30 and 50 are multiplied, other side divided. So 22.48 divided by 50 into 30. This will give us the average thickness, which is 0.015 centimeter. That's the average thickness of this sheet. So first we calculated the volume by using a formula that mass divided by density is equals to volume. And after getting the volume, we know that rectangular sheet should have a volume of length, width, and height or thickness. So we work out the thickness. A student has a large number of the coins of different diameter, like different size of student is having coins of different size and all made from the same metal. She wishes to find the density of the metal by a method involving placing the coin in water. So state the formula that she should use to calculate the density. So density is equals to mass over volume. How the measurement of required quantities are carried out, like how she will perform this, how she will work out it is a 5-mark question. So you have to just write a short experiment. So how it can be done? So we will first, because we'll use a displacement method, we'll take a measuring cylinder. We'll take a measuring cylinder and we'll fill with water. So we'll record its volume. Then we'll add the coins. We'll add the coins. The volume will change because the displace will measure the final volume and take a difference. V2 minus V1 will give us a volume of all these coins. Like take 5 or 10, any number. And then we can measure the mass of all these coins by placing them on the balance. So place them on the balance and measure the mass. Now to get the density, how to get the density is mass over volume. So how the marks are distributed for this? First thing you will mention, like we'll take a measuring cylinder or a graduated cylinder. Then we'll fill it with water. Then place the coins inside, record the volume, measure the volume, and then calculate the difference to get the volume of the coin. And then measure the mass of the coins by balance, and mass divided by volume will get the density. Is it clear? This experiment? Anyone having a doubt with this?
No.
State one precaution that when carrying out the measurement, ensure the results are accurate. So what are the precautions we should take whenever we are doing this experiment? First thing, we should always look for the bottom of the meniscus. Like when we are reading the scale, we always look perpendicular, look for bottom of the meniscus, like look perpendicular is separate, looking for a bottom of the meniscus separate, avoid like splashing when adding the coins. Like we should not push the coins or drop the coin from a greater height, so the liquid might splash. As a result, the volume won't be accurate. So avoid splashing. And for a balance, for this balance, reset the balance or check for zero error, you can also mention. In question 9, a scientist need to find the density of a small rock, sample of a rock down a mine. He has only a spring balance, a measuring cylinder, some water, and some thread. Look, spring balance cannot measure the mass, it measures the weight. So what we'll do, like using a spring balance, we'll get the weight of this sample of rock. And our weight divided by gravity will get the mass. In a space below, draw two label diagram, one to show the spring balance being used. When they say label diagram, we should label like this is a spring balance, rock sample, support is there. Same way a measuring cylinder. So we'll fill the measuring cylinder with liquid. A similar experiment what we have discussed. Then with a rock sample, look perpendicular and label this. Measuring cylinder is there, water, rock sample, I, and you can label the meniscus as well. So look for the bottom of the meniscus. So measure initial volume, measure the volume with rock, then subtract to get the volume of the rock, hang it with a balance, a spring balance, measure its weight and calculate the mass. Weight divided by gravity will get the mass. And how to get the density? It will be mass divided by volume. So the spring balance is calibrated in Newton. State how the mass of a rock sample may be found. So how we can find the mass of the rock sample? Mass of a rock sample will be weight divided by gravity. State the reading that would be taken from measuring cylinder. One is only like volume of a liquid, which is V1. Another one is a volume of a liquid plus volume of rock. That is V2. How the volume of a rock could be found? So by subtracting V1 minus V2. And what equation we'll use? So mass divided by volume, we'll get the density. What is meant by the term weight? So weight is force of gravity acting on the object. Can we say that volume will increase? So weight is a force of gravity acting on the object. And density is the mass present in unit volume. A student is given a spring balance. A student has told that the acceleration of a free fall is 10. Acceleration of a free fall means like the value of the gravity. How a student could find the mass of an irregular solid. So how student could find that, because a spring balance, so we will use a spring balance and find the weight. And then how to get the mass? So mass is equals to weight divided by gravity. So divide the weight by gravity, will get the mass. Then how student could find the density of an object? So if you want to work out the density of an object, density, so we can take a measuring cylinder, the same answer, fill the measuring cylinder with liquid, record the volume, then add object to the measuring cylinder, record the final volume. So, and take a difference to get the volume of object. Question 11, a student use a suitable measuring cylinder and a spring balance to find the density of a sample of stone. How measuring cylinder is used and state the readings that are taken. So we'll measure the volume of water first, that is V1. Then we will add object, measure volume of water in object. That is V2. And then we will find volume, which is equals to V2 minus V1. And look perpendicular. Describe how a spring balance is used. So the same answer, using a spring balance, first we'll find the weight. Describe how spring balance is used and state the reading that is taken. So how we can, because we want to find the density. So to get the density, we don't need weight, we need mass. So first we'll find the weight, and then weight divided by gravity, we will get the mass. So first find weight, and then mass is equals to weight divided by gravity. Write down equation for finding a density of a stone. So density of a stone is mass divided by volume. A student wishes to find the density of a cork. Suggest how the apparatus and the method would needed to be changed. Look, a cork, because usually it's made up of wood or a rubber, so these objects float. So if it float, it means it will be difficult to measure the density, because we can measure the mass, we can measure its weight and the mass, but we cannot find its volume easily as it float. So what we have to do for these type of objects which tend to float, how to get the, because getting the mass is the same thing. So first we'll fill the measuring cylinder with liquid and we measure its volume, that is V1. Then example, if this is representing a cork, if this is representing a cork and we attach another object which sink, which we also call a sinker, like any object, any metallic object. So there will be a sinker and a cork is attached. Now, what we will do, first we'll add sinker. So volume will change. That volume will be V2. This is the volume of the sinker plus water. That volume is V2. And third, what we will do, like because the sinker has a tendency to take, as it tend to sink, it will take this object inside. Otherwise, without a sinker, if we place an object, a sinker can be any metallic object, the object which tend to sink, having a density more than the density of water. So the sinker will take this object inside. So this volume will be V3. Now, if I want to calculate the volume of this object, like this is a cork, and whenever you draw any figure, it should be label diagram. So this is a cork. This is V3. If I want to measure the volume of the cork, so then I should only do V3 minus V2. When I subtract V3, like V2 and V3 with each other, I'll get the volume of the cork. So only modification, whenever a floating object is there, object which float, we use a sinker. Is it clear, this one? Then the list below gives an approximate density of the various metals are there. An antique market, a collector buys what is advertised as a small ancient gold statue. And when the collector tests in the lab, he finds that the mass is 600 and the volume is 65. In a space below, how volume of a statue can be measured? So how we can measure the volume of the statue? Fill the measuring cylinder with liquid, but whenever you draw any diagram, it should always be level. And then you can use a displacement method, or you can use a measuring cylinder. In a displacement method, we just add completely fill it with water. And then when we add an object, the liquid will displace. How much liquid displace? That is equals to volume of the object. So this is a statue, small statue is there. Because it's like 600 gram and 865 cm cube, which is a very small volume. So this volume is V1, this one will be V2. And then use a figure, give above this whether the statue is made from gold. So how we know the statue made from gold? We'll find the density of the statue. The density is mass over volume, so 600 divided by 65, which is 9.2. So 9.2 gram per centimeter cube, but the density of the gold is 19. Density of the gold is 19, but we are getting 9.2. So what is this statue made from? It is made from copper. So statue, because if the statue was made of gold, then it should have the density same as the density of a gold. As even we take a small amount or a large amount, the density won't change. We are getting 9.2, but it should be 19. So it's not made from gold. So was the statue made of gold? Take a box. So that is no. So this was exercise related to measuring mass, weight, and density, the structure questions. Any question or a doubt related to the session today?
Sir.
So solve this exercise along with the multiple choice question and submit tomorrow.